Hello, everyone, and welcome to another episode of GDDV 106 Development Concepts. My name is Kasanas. Well, guys, this is actually a continuation of the previous episode. I realized that I had recorded for far too long. I don't like you guys to have to watch more than about 15 to 25 minutes in any given episode, and I was gone on way too long. So this is just a continuation of the physics episode. So far, we've done a lot of stuff here. We did the course intro to Unity, C#, logic control, UI, and last episode we actually did sprites. That's where we didn't even get to physics. We got to sprites. So in this particular episode, guys, we are going to be taking a look at the physics options. All right, let's get started. Okay, guys, so let's finally actually get into this. We're finally going to take a look at physics here. And we're really going to talk about three different components today: rigid body, collider, and trigger. And these are extremely important. These are extremely important components. In fact, if you don't learn anything else about physics, if you know these three, then you're in pretty darn good shape as far as making games is concerned. We're only going to cover these three components, though. And there is a version for both the 2D and the 3D physics engines for all three of these. Let's start off by examining the rigid body. And the rigid body is basically what tells the physics engine that this is something that I want to be affected by the physics engine. That's why you add this component. As soon as you add in the rigid body, the element or the object, the game object you've added the component to, will be affected by whichever engine that you've set it up for. So if you've added a rigid body 2D, then it's going to be affected by the 2D engine. If you've added a rigid body, it's going to be affected by the 3D engine. So simply by adding this component, suddenly all the forces will potentially, I mean, you can have settings so it won't happen, but potentially all of the forces will be able to interact with and affect this particular game object. That's the point of it, all right? If you want to add yourself a rigid body to a 2D element, you're going to hit the Add Component button. We'll take a look at this when we're in Engine in a moment. You hit the Add Component button, you'll go to Physics 2D, and then you'll go to Rigid Body 2D. If you wish to add a 3D component, you're going to go to the Add Component button, you're going to click on Physics, and then you're going to select Rigid Body. And in both cases, they are slightly different. So these are the settings that you'll find once you've added the component into your Rigid Body 2D element, your 2D object. These are the variables that you'll see, and these are the variables that you will see for a rigid body. This is our Rigid Body 2D, this is our Rigid Body 3D. Okay, so they're not identical. However, they do have a number of identical elements. And the reason why I'm showing you the difference is because I'm not going to explore both when we get into the engine itself. I don't think I am anyway. This is going to be a long video, I think, today. And I don't like making long videos, in all honesty. I think you guys get bored of long videos. So let's go on here and take a look at the common elements. And then you can play around with the 3D version once you're doing 3D stuff. So the common elements across the rigid body components are mass, drag, angular drag, collision detection, and constraints. Those are all the common ones. Now, these are the most important ones that you should know anyway. The mass. By setting a mass, you have to understand that larger objects with larger mass will be less affected than objects with a smaller mass by gravity or by interaction. So if you've got a large mass object that collides with a smaller mass object, the force will be transferred more into the smaller mass than it will be into the larger mass, right? It takes more to move a larger mass. Think of it in real world terms, right? If you were going to try and push a car, it's harder to push a car than it is to push a marble, right? One has depends on how big it is, I guess, or the mass of it. If it's a giant marble, maybe not. But anyway, the larger mass object is obviously harder to affect through physics. All right, it requires more force to affect through physics. Drag is how much an object will slow over time due to resistance of some kind. And that could be air resistance, it could be, friction, whatever it is that, air friction or friction along a surface, whatever it is, it's how quickly an object will slow down over time. The higher the drag, the more the object will slow down, the more that the friction is going to slow it down. Angular drag is the same thing, but for rotation. So the higher the angular drag, the faster an object will stop rotating. If you apply a force, an angular force of some kind, and cause it to begin rotating, a higher angular drag will cause it to slow down quicker than a low angular drag. Collision detection, there are a number of different options. There's discrete, continuous, continuous discrete, and continuous speculative are the four options. By default, it'll be discrete. And there's different, this is when it comes to the idea of the collision of two objects. This is what it really means, the collision of objects. If you have it set in continuous, then fast-moving objects interacting with static objects, it allows that fast-moving objects to interact better with static objects. In continuous discrete, fast-moving objects interacting with physics objects, and in continuous speculative for dynamic and kinematic objects, we'll talk about those in a minute, but problems can occur with fast-moving objects. So depending on which one you've chosen, you can end up with some issues of some kind, right? Normally, if you have something where you want it to constantly be looking at the collisions that are occurring, you're going to want to set up to continuous or continuous discrete. If you've got really fast-moving objects, one of the big problems with the Unity engine that if objects are moving too quickly, the collisions can be ignored in its default mode. If it's going too quickly, then it'll be ignored. So if you have really fast-paced objects within your scene and you're hoping like a bullet, let's say, and you've applied a force to this bullet and you want this bullet to interact with a character every time that it hits the character you want to interact, if it's traveling too quickly, the collision will be completely ignored by Unity. You'll want to set it up to either continuous or continuous discrete. Okay, and the last one is constraints, and the constraints basically prevent an object from moving in some way. You know, I'm talking about this, and I think it's probably better off if we head into Unity and we take a look at the RigidBody. Okay guys, so here we are inside of Unity once again, and I've gotten rid of the other sprites. They're unnecessary. And what I've got here is our circle. All right, I've added a circle from my basic sprites option. And you can see that this circle has all of the same elements that we expected from before, all the same components, transform and sprite renderer. What I'd like to do now, if I hit play, watch what happens. Nothing. Nothing's happening, right? That sprite is just sitting up there, a dot on our screen. And that's what we expect because we don't actually have any of the elements that say, you know, physics engine, do something to this particular object. So what we're going to do is we're going to go to our add component button. We're going to click add component and we're going to go down to our physics 2D. When I go to physics 2D, I have the option to add into this a rigid body. So if I scroll down, if I'm looking for it, I scroll down, there is my rigid body 2D. Okay, and when I add it, it automatically adds into there my RigidBody 2D component. Now we have a number of different things associated with this. Right now at the very top, our body type is dynamic. We have kinematic and static. Dynamic means you affect me, physics affects me in some way, in every way, all right? It'll accept forces and automatically be applied, have forces applied to it. Kinematic means don't apply any forces to it. It's going to ignore gravity. Actually, let's take a look at this. We'll take a look at it in a second. And lastly, static means I'm unmoving. I'm unmoving. And maybe you'll ask, like, why would I want an unmoving physics object? There are many different reasons why we might. Rigid bodies are required for communication across a public variable, across a public function. And we're going to talk about the idea of public functions in a later video. So we've got all these different things here. We've also got the material, and there's physics materials here. We'll talk about physics materials as well today. We have so much to do. I think I'm going to have to make two separate videos, actually. I think we'll have to. Materials themselves will allow us to add a physics material to our object, and that's going to allow us to adjust things like how much drag a particular surface has or how much bounciness is associated with a particular surface. That's all available to us there. Here we've got our mass, our linear drag, our angular drag, our gravity scale. So in mass, as we already talked about, is how much weight it has, basically. It's not really that. There's a difference between mass and weight, but we won't get into that. Think of it as how much it weighs for simplicity's sake. Linear drag is how quickly it'll slow down over time. Angular drag is how much the rotational drag is on this particular option. Gravity scale is how much gravity is affecting it. Right now set to 1 means it's 100% affected by gravity. If I take a look at collision, we already talked about this, the idea of discrete and continuous. There's also there's several other ones there, but discrete and continuous. Discrete was if you have fast-moving objects, you want to go to continuous. Just make sure you know that. Sleep mode means that you can actually start off this thing so it's not actually able to be collided with. So never sleep it'll automatically be available. Start awake means it'll be awake for a certain amount of time, and start asleep means turn off the collisions basically. So be careful of this. Sometimes if you wait too long and you only have it set on start awake, then after a certain amount of time, your object will go to sleep and it'll start ignoring any of the collisions that are occurring. If you find that happening within your game, and we're going to talk about this a little bit later on when we start to talk about colliders later on, actually. When we start talking about the idea of colliders, we'll take a look at these ideas as well. Below that is constraints, and this is going to in some way isolate what we can do. So freeze position and freeze rotation. So don't allow it to be moved in the X or the Y, and don't allow it to rotate in the Z by turning these things on. Without anything clicked on, the constraints are not available, and this thing will be allowed to rotate and everything else. But there's nothing for it to actually interact with right now within the scene, so nothing's actually going to happen right now. Below that is our information. We can see a number of different things in here. There's a couple of things that are really important. Velocity is an important one. I mean, all these things are important. This just gives you information about the particular object. So let's take a look at what happens now if I hit play. When I hit play now, our ball is automatically affected by our gravity settings, and it is being dragged off the scene. If we go back to our edit and we go down to our project settings and we change our physics 2D into, let's put 0 here, and let's give it an X value of, let's say, 10, and I close this off, now when I hit play, our object will be dragged in a different direction, all right? So now we're applying gravity in an entirely different direction. So I just wanted to demonstrate that. We talked about it previously, and I wanted to demonstrate it. So project settings, let's put this back to 0. And let's put this back to negative 9.81. So we've got our gravity where it should be. All right, and that is the entire purpose of the rigid body. All right, let's head back into our lecture now, and we'll talk about the next component. Okay, guys, so the next component I want to talk about is the collider component. And really, the collider and the trigger are basically the same thing. There's just a subtle difference in the two. So we're going to talk about both of them together right now. And a collider basically provides a surface which can bump into another surface. Another object with a rigid body can bump into a collider. All right, two things that collide together. Basically just allows things to bump together. That's what it does, right? It creates a surface that is going to, a hard surface that's going to allow things to bang into one another. There are several different types of colliders. Here I have an example of a circle collider, but they're across both the 2D and the 3D engines. There are probably 50 different types of colliders, and we'll examine those in Engine in just a moment. There's probably 50 different types of colliders, though. There are a bunch that'll meet whatever needs you actually have. But they all do the exact same thing. They all do the same thing. Now, it's important to note that there are collider 2Ds and there are colliders. The collider 2Ds work with the 2D physics engine, and the collider 3D only works with a 3D physics engine. A collider 2D will not in any way interact with a collider. All right, the 3D engine version. It will not in any way act. They'll just pass through each other. The next component is called a trigger. And something here I want you to take note of. The collider, where it says is trigger right there, is not checked. And when I go to the next slide here, the is trigger is checked. That is the difference. If you want to create a trigger, all you do is you click on the is trigger option, and this component, this collider, becomes a trigger. And the difference in a trigger and a collider is that a trigger will create a surface that other colliders can pass through. So that's really what it does. It's just an area that acts as an area which you can detect if another collider is inside of it. That's what a trigger is. If a collider enters into a trigger, it will start an event saying, hey, something's in here. That's really all that it does. That's the real difference. So two colliders will bang into each other. A collider and a trigger will pass through each other. Two triggers will pass through each other. All right, so if you've got two triggers, pass through. If you've got a trigger and collider, they will pass through. And if you have two colliders, they'll bang into each other. Now, in any event, what occurs, there are a number of different events that can occur depending on what you've got going on. If you have two colliders that bump into each other, you can have an on-collision enter, an on-collision exit, and an on-collision stay event. Now, each of these do something different. On-collision enter occurs when two colliders first bump together. It'll throw an on-collision enter event. Whenever that collision stops, so whenever they are separated, an on-collision exit will occur. You first have to have an on-collision enter, and then it'll give you an on-collision exit once there's no longer an interaction between those two objects, when they're no longer bumping together. And as long as those objects are bumping together, as long as they are in contact, we will have an on-collision stay event that is available to us. And these are all events that are available in code. These are 3 opportunities for us to issue code whenever this type of a collision occurs. Similarly, with triggers, there is an on-trigger enter, an on-trigger exit, and an on-trigger stay. If a collider and trigger come together, or two triggers come together, for the first moment they touch, there's an on-trigger enter. When they separate, there's an on trigger exit, and as long as they are together, we will have an on trigger stay. And again, that can be affected. Remember before when I showed you the never sleeps and stays awake? When this can be affected by that. If you don't have it set up so it's continuously looking to see if there's an event, the on trigger stay event can be short circuited in some ways. After a certain amount of time, it shuts itself off. So what exactly does this mean? What exactly are these events? Well, like I said, they are available through code. And the code itself will be set up like this. Private void on collision enter 2D, and it takes a collision parameter. And you do something with those collision parameters. So something will occur whenever a collision occurs. Private void on collision exit 2D takes a collision parameter. And again, within the code, you can do something whenever the collision stops. And lastly, private void on collision stay 2D takes a collision parameter, and as long as these two elements, these two objects are in contact with each other, this event will be issued over and over and over again. Okay, so that is the on collisions. Very similarly are the on triggers. Private void on trigger enter 2D, private void on trigger exit 2D, private void on trigger stay 2D. As long as these conditions are met, we will be able to do something as far as the code is concerned. Now, there is a very obvious difference as well. The difference in the two. In the on trigger enter event, we have a collider 2D as the parameter, and in the on collision enter 2D, we have a collision 2D. Okay, so it takes two different parameters, a collision 2D with the collision and a collider 2D with the triggered events. Okay, and in each case, you can do something. We'll take a look at this in code in just 1 second. And this is what I've already mentioned. So the on-collision events takes a single collision. A collision class contains information about the colliding object, the game object relative to the velocity, contact points, etc. An on-trigger event takes a single collider parameter, which gives information about the collider that is interacting with the trigger. All right, so the collision will give you a little bit more information as far as the velocity of the two objects and everything else are concerned, whereas the trigger just says, hey, there's a collider in here, and it'll tell you exactly what that collider is. That's the difference in the two, really. And obviously, the difference as well is that one allows pass-through and one doesn't. So you'd use a trigger if let's say you wanted to know if a player entered within a specific area, well, then you'd use a trigger to allow the player to enter into that area, and you use an on-trigger enter event to say, okay, the player's now here, end the game, or start the game, or start the fight, or whatever it is you want to occur. Okay? Last thing I want to talk about before we head into Unity and take a look at all the stuff is physics material. And we touched on this very, very briefly. One of the variables that is available within the collider is a material, a physics material. And the physics material itself is going to allow you to set up how the interaction between those colliders occur, or the collider and the trigger occur. We can set it up so there's an amount of friction. And again, it's different if you're talking about 3D or 2D materials. The amount of friction there is, the amount of bounciness there is, all of these kind of things can go into the definition of a physics material. Actually, we'll take a look at all of this inside of the engine because it's probably easier to show rather than simply to explain. Okay guys, back inside of Unity, and we've got our falling ball here. Now let's say I wanted this falling ball to actually bump into something. Let's say I want it to bump into a platform of some kind, so I'm going to dump a platform, let's say right here. Let's just zero this out. Let's just put it at 0 and 0. All right, let's say, actually I'm going to lower it. Let's just so it can fall farther and you can see it. It'll give us more reaction later on with our physics material. All right, so let's say I want this ball to interact with this platform. I want the ball to hit the platform and, bounce, let's say. When I hit play right now, our ball is going to pass directly through that particular object. Now again, guys, you saw these are both on the same sorting layer. If you were actually setting this up, you might want to set up your sorting layer so the player's, let's say, on top. So let me just set up our platform so it's at a -1 for now. All right, so now our ball will always appear on top of this particular object. So let's set this up so that they are going to collide together. And in this particular situation, I need a collider on both the ball and the platform. So with the platform selected, I'm going to go to Add Components. I'm going to scroll down to Physics 2D. I'm going to then find a collider that's appropriate. And look how many colliders there are here. Box collider, capsule collider, circle collider, composite collider, edge collider, platform. No, it's not platform vector. Beep, 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 beep. That seems to be it. For 2D, that's all we've got are those couple. If I actually wanted to add a 3D, let's say a physics 3D. I've got box collider, capsule collider, I've also got mesh collider, sphere collider, terrain collider, and wheel collider. So there's a whole bunch of different ones depending on what you want to add. So I'm going to add myself in here a physics 2D, and I'll add in this is kind of box shape. So I'm going to add myself in a box collider. And it's hard to see, but what's happened here is there is now a green line that is wrapped around this particular object. I can also see that down here inside of my inspector, I now have a box collider 2D option available. That component has been added. Now, let's simply do the same thing with the circles, just so you guys can see how this adds. I'm going to go to the circle collider. I'm going to scroll down. I'm going to say add component. And in this particular case, we've got ourselves a circle here. So let's add ourselves a circle collider. All right, if I go back to my circle, I've now got this green circle around my actual object. If I hit play now, my object's going to fall, and boom, they've collided together. And you saw how it instantly stopped. And something else you're going to note is the space that we have between our two objects. So those two objects are colliding wherever the colliders are set. And if we scroll in here, we can see that the collider is too large for my ball. And if we go down to this one here, it is too large for my platform. It's defined by in terms of the actual sprite that you've put in. Now, we can edit the collider so it more closely matches what our terrain looks like. In the collider 2D, box collider 2D here, I've got edit collider. And if I simply click it, I'm allowed now to adjust the size of this collider. And I've got these little handles now here that allow me to drag my collider how I want. So I'll drag those in so they're nice and tight on there. All right. And now I've more closely defined the collider as far as that box is concerned, as far as this platform is concerned. When I'm done, I can turn it off. And I can see now the outside edge of my sprite, and now my collider is that green line on the inside. I'm going to do the same thing with my circle. So if I click on my circle, again, I can either go in, if I go down to my collider down here, I can click on this, or I can adjust this if I wanted to. So I can adjust this physically. So here where it says radius, if I wanted to, I can simply scroll and make it bigger or smaller. All right, so depending on what you want to do. If you want it exact, you can go in and you can adjust it with this way, or you can use the values that are available to you under the radius. Same thing with the platform. We actually had values for the box collider. We can adjust the size of it as we wished. Okay, so now when I hit play, our ball is going to appear to come into much better contact with our particular platform. I probably want to adjust that a little bit more to make sure that it seems like it's sitting on top and I don't actually have this little space. Depending on how far back your camera is, it's going to look better or worse. Okay, let's hit stop here. And let's see what happens if I make one of these a trigger. So let's say I decide to make this circle a trigger. All I have to do is go into my circle, head down in here and say is trigger and turn it on. All right, and when I hit play now, my object will simply pass through. Okay, so the trigger allows our objects to pass through. Let me turn off our trigger for now. If we take a look at what this is going to do as far as our physics is concerned, so we saw how the ball simply struck the platform and stayed in position. We can actually set it up so that things will occur. Now, let's actually add in one of the heads so it's easier to see. I'm going to go back to my sprites here. Let's add in a head. Let's add in our head a circle collider, so our physics 2D circle collider. There's our circle collider, and we'll just leave it like that. If I hit play now, both of our objects will fall. Oops, I didn't add a rigid body, so they won't both fall because I don't actually have a rigid body on the head. Add component, physics 2D, a rigid body 2D. Now when I hit play, both objects will fall. Bang, and they both hit. Okay, awesome. Let's adjust this particular object. I'm going to simply add a little tilt to it. Shoop, just like this. And let's move it over a little bit so our head still hits it. And let's hit play and see what happens. So now the objects are going to roll down that particular slant, okay? So they're going to roll down the slant. And if we hit play again so you can see it, you'll see that the head is going around in a circle and rotating. The constraints option are going to prevent that from occurring. So again, if I go into the head, I scroll down to the rigid body, I find our constraints, and I freeze our rotation. And now when I hit play, watch what happens to the head. So in that particular case, we have frozen the rotation. It is no longer allowed to move in that direction. It's no longer allowed to rotate. So that is what the constraints will do for you. Okay, so before we go ahead and take a look at the interactions, because I want to take a look at the coded interactions as well, let's take a look at what happens when I create myself a physics material. I'm going to go over to my assets. I'm going to right click and I'm going to say create, and I'm going to create myself a brand new folder, and let's just call this our materials. All right, our materials. And I'm going to double click in there to open it up. Now what I'd like to do is add myself a brand new physics material. To do so, I can right click anywhere in the gray. I can again go to create, and I can find the option for physics material. And I can never find it in here, down here, physics material and physics material 2D. Now, again, obviously, we're going to need a physics material 2D if we're going to want to make this operate with 2D. Physics material 2D, and I've got a brand new thing down there that I can see right here, and let's give it a brand new name. I'm going to call this, let's say I want to make this thing bouncy. Let's call it our bouncy. All right, our bouncy. I probably should think of a better name than bouncy. Anyway, our bouncy. Let's take a look at our materials here. We've got ourselves our friction and our bounciness. And if I want to increase our bounciness, I can make this bouncy. Let's add a big value here. I won't make it too big. Let's make it, let's say 10. That might even be too big. All right, now I'm going to go back to my platform. And under my platform, under my collider, I'm going to add in my bouncy material right here inside of my material, inside of my physics material. I'm going to drag it, and I'm going to drop it in place. And now I have a bounciness applied to this particular object. Watch what happens when I hit play now. Boing. So the head bounced away. It's absolutely gone. The head is gone forever. If I want to make it less bouncy, I just want a little tiny bit of bounce to it. Obviously, we can adjust this. Let's make this new a bounciness of 1 and see what happens. Play. Bounce, bounce. All right, perfect. Perfect. A perfect amount of bounciness. Hit play. Bounce, bounce. Perfect. All right, guys, that is your physics material. So you can get a lot of this for free. Let's say you're making a tennis game, or you're making a game where you want the grenades, you throw your grenades and you want them to bounce a particular distance or whatever. You could absolutely add in a bounciness. Friction, if we reverse this instead and we created a high level of friction, we're not going to be able to roll as well. So let's say I set this to 0 once again, and I set a super high friction value. Let's put our friction at, let's say, I don't know, 100. Make sure it doesn't move, and I hit play. There we go. Our head, which is no longer allowed to roll, is stuck there, and our ball has rolled away. I actually don't know why. That's interesting that it's occurring. Let us decrease this value to, let's say, a 1 as far as friction is concerned. I think I might have been too low. Let's put it at, let's say, 5 as far as friction is concerned. Hit play, and let's see what happens. All right, same thing, our head is stuck there. If I slow it down, let's put it at a value of, let's say, 0.6. Let's see what we get going on. There's going to be a slower roll. So it's still rolling, just slower. Interestingly, our ball appears to be rolling faster than the head. And in all honesty, I don't know why. I don't know why. They both have exactly the same type of collider. They both have a circle collider on them. So I don't know why one is rolling faster than the other. Interesting. I'll have to look into that for you guys because I don't know the answer to that. All right, guys. So that is our physics material. What I'd like to take a look at next is the different events that can occur as far as the collisions are concerned. I'm actually going to step off and write a bunch of code and then come back and show you the code because I haven't done that yet. All right, guys, I'll be right back. Okay, guys, so I've written 2 really short scripts here. I've got my collider interaction script, and all I've done here is I've got the OnCollision enter 2D, the OnCollision exit 2D, and the OnCollision stay 2D events that are being caught. Each one of these takes a collision 2D parameter as well. So when the contact first occurs, we're going to see collision started, and we're going to print out the game object that has come in contact. So I've taken this collision object right here, and I'm printing out the game object. There's a whole bunch of other choices. You can print out an array of contact points. You could print out a number of different things that are available with a collision. Take a look at all the things that are available. If you want to see what's available here, what I could have printed out, you could just hit the dot right here, and it will tell you all the things that you could actually get from this collision information. All right, just to keep it simple though, I'm going to say game object solely. If we go down here, we're printing out collision ended whenever the contact stops, and we're printing out collision ongoing as long as these two objects are together. Let's save this file, save. Over here is our trigger interactions. Our trigger interactions is almost identical in nature. Instead, it's just to do with triggers. I've got my on-trigger enter 2D, on-trigger exit 2D, and my on-trigger stay 2D. In this case, it takes a collider. So I've called it other, and I'm printing out on-trigger enter when the triggers first come together, when the trigger first enters into the collider, or I guess the collider first enters into the trigger. I print out trigger entered. Afterwards, we print out the name of the game object that actually triggered the event. Same as we did with the collider. And then as long as they are in touch with each other or inside of each other, we'll have inside of trigger. And lastly, when they're no longer together, they've separated, we'll have our trigger exit. Okay, so that's what we've got going on here. I've gone ahead and I've added the information to the circle. So right here to the circle, I have both of these scripts. So our collider interactions and our trigger interactions. Obviously, if this is set up as a collider, we won't see any of our trigger interactions, and we won't see any of our collider interactions if this is a trigger. All right, so as long as it's a collider, no trigger. If it's a trigger, then we won't see any collider. So right now we are set up to be a collider. Trigger is turned off. So watch what happens when I hit play. Oh, I've got a number of different things. I've got maximized on play turned off, so we're going to see it occurring here. I've also got collapse on. So instead of seeing a whole bunch of lines, we should see on trigger. We should see on our collider entered. We should see then the game object listed here. We should only see one line of contact occurring. Whatever I said there, I forget what I said, and it'll give us a number of different times that it occurred, and then one line where it says exit. That's what we should see here. If you don't have collapse on, it's going to show you the long list of every second that it's actually in contact. All right. So if I hit play here, watch what happens. There we go. And we got our collision started. We got the name, the platform. That's where it occurred. So we collided with the platform. And then lastly, we had then we had collision ongoing. And lastly, we had collision ended. Take a look here. We had 31 different events that were thrown as long as this was in contact. So collision ongoing occurred 31 times. So whatever code I had within there would have occurred 31 times. Maybe let's say you have a character who takes damage as they're walking through fire. Maybe you want to have it set up so they take damage constantly while they're on fire. I mean, 31 times is a lot to be on fire. Anyway, guys, that is the collision. Let's try it one more time when I hit play. There's our collision, there's our ended, and again, 31 times that's occurred, all right? And again, it's printing out the fact that it's our platform that we've collided with. Okay, let's change this to a trigger now. Our ball is now a trigger. I'm going to clear this, and I'm going to hit play. Let's see the difference. This time, our ball is going to pass through, and there it has. We again had our trigger entered, as we expect, one time. We have the platform is what passed through the trigger, so we see that one time. Inside of the trigger, we remain in there for 14 different times, and then trigger exited. So pretty much the same, just the amount of time it spent inside of the object was different. All right, guys, and that's it. So we can make anything we wanted happen there. Let's say whenever a player touches an obstacle, we want that player to die, right? Well, then what you would do is you would set it up so that if the player entered into a trigger area, it would then call a public function that would kill off and destroy our player. Or if you want to set up on the player itself, whenever the player entered into the area, they would automatically die. It would destroy the player. Okay, so that's what it's going to be used for. We're going to look at that really, really thoroughly later on when we start talking about the idea of pickups. Okay, so that's it, everyone. That's all I really wanted to show you. That's what I really wanted to show you today. Everything here is working exactly as we expect. We've got different options as far as the collision events and the triggered events are concerned. Use the one that you think is the right one for the job. All right, if you simply care about when they're touching, you're going to use your collider. And if you're worried about when they pass through each other, you're going to use trigger. All right, guys, that takes us to the end of this video. I think this was a long one. I think it might have been a long one. I don't know. I've been talking for a long time. Made a lot of mistakes. This is the first video that I'm actually recording today, and I make a lot of mistakes when I first start recording. Anyway, guys, I hope you enjoyed it. If you did, let me know down below with a thumbs up. If you didn't, let me know with a thumbs down. Tell me what I can do better. All right, I'm always interested in improving. Guys, I'd love to hear from you. Comments, all right? Lots of comments down below. All right, everyone? Thumbs up, thumbs down, comments down below, and if you haven't done so, please take a few seconds to subscribe. Have yourselves a wonderful day, everyone.